61A, lecture number 36, Q&A. None of the questions were about the lecture, but we had some good questions.
Yeah, good question. So, questions about how halving is used. Halving is really designed to filter out whole groups. So, for example, the second option here, select star from records group by division having count star greater than 3, is going to give you all the rows from records where there are at least, like, you're going to get one row per division, but only for the divisions where there are at least records, 3 records, or more than 3 records that have that division. So that is like a well-formed thing. Let's look at this other example that you suggested, which tries to filter within a group. I don't think this is going to do the right thing. So still you'll get 1 row per division. It's going to evaluate this thing that says salary equals max salary. What that's going to do is it's going to compute the max salary for the group. It's going to find the salary for a particular element within that group, because when you perform a max, it tends to select the record that has the max. I'm guessing this will always be true, and what you'll end up with is 1 row per division, and this halving clause won't really do anything at all. So if what you want to do is filter out individual rows from records before you perform a group, you need to use a where for that. Yeah, I mean, anytime you're mixing an aggregation with a selection of a single record, it's really not something you can trust. Yeah, I guess I'd have to look at the example to tell you what's going on in a particular implementation. But probably what it didn't do is just filter out rows before doing the grouping. Instead, what it did is it grouped, and then it kept some of the groups. But I think in this case, it would probably keep all the groups.
Okay.
Yeah, so the question is, how do you find the rows that have the maximum value in them? Actually, this will in SQLite do that for kind of a quirky reason. It's not that the salary equals max salary will do the trick. It's that just computing max salary will order the rows within a group. And then when you select star, where you're really selecting a particular row from a group, it's going to select the first one. And because you ever took a max somewhere, it happens to be that that first one will be the one with the max salary. So it's true that this will work. Not a behavior we want to rely on. Instead, if what you want to do is figure out what the max is for each group and then select a corresponding row with that max, I think that's a 2-step operation. You want to create a table with the maxes. So something like select max salary, comma, division from records group by division. Now you know what these things are called, but you should give that a name, maxes. And now you have a table that's 1 row per division and tells you what the max salary is in that division. Obviously, this won't run because I don't have a records table loaded, but then you do a second step where you would select star from the result of joining together the records and the maxes. And here's the case where you'd make sure that you only want the records that have the right division. So you, let's say we call this A, and call this B. Now you're going to have 1 row from the max table, 1 row from the records table. You want them to match. A.division equals B.division. And you're only interested in the rows that have a maximum salary for that division. So that will be the A.salary equals B.salary. Well, B.salary here is representing the maximum salary for the division. A.salary is the salary for that record. This would filter out all the rows where somebody is in the division but doesn't have the highest salary within that division. Okay, so now we've filtered out the rows that we want, and we can perform a group by. So doing it in 2 steps like this obviously is longer than relying on this ordering behavior, but I think it's more explicit about what's going on.
The next question was about the Fall 2019 Final Exam, question 6C.
All right, let's get a sense of where we are really quick just by reading through. A palindrome is a sequence that has the same elements in normal and reverse order. We've already implemented pal, which takes a positive integer n and returns a positive integer with the digits of n followed by the digits of n in reverse order. So we could like build a palindrome out of some prefix. We did contains, which contains non-negative integers a and b. It returns whether all of the digits of A also appear in order among the digits of B. Okay, that might be useful. So 3, 5, 7 is in here somewhere because there's the 3 and there's the 5 and there's the 7. But 7, 5, 3 is not in there because they're in the wrong order. All right. And now we're going to implement big, a helper function for biggest palindrome. The biggest palindrome function takes a non-negative integer n and returns the largest palindrome integer with an even number of digits, okay, that sounds important, that appears among the digits of n in order. Okay. So largest palindrome integer means longer is larger, but also like to break ties, we're going to have a kind of large first digit. If there's no even length palindrome, then we should return 0, okay? You may call pal and contains. But we're not allowed to turn things into strings or lists or tuples or use square brackets or anything like that. So it sounds like we got to just use integer manipulation, like dividing by 10 and stuff like that. Biggest palindrome calls big on n with 0 as some starting value for k. And this is the helper function that is going to track something about what we've seen so far and is also taking digits from it. If n is 0, then the biggest palindrome within it is 0. Here we have choices. There are 2 of them, so you can kind of look at the structure of this expression and see there's 2 options. We're going to recursively call big, keeping k the same, or we're going to recursively call big, making k bigger somehow. All right, if contains k, remember contains, the way it works is that the numbers that you're looking for come first, and then the numbers that may contain k come next. If contains k something, then we will return something. Otherwise, well, it's not clear what we'll do here, but we'll have to try to figure that out. Otherwise, we return the max of choices. Here's what I think I know so far. At some point, you're going to ask whether k is contained in n in order to decide if it's the case that we found a palindrome. So, and here it's kind of like, do we use the last digit or we don't, is the typical pattern that you see when you're recursively searching for digits that are inside one number and not inside the other. So I'm not totally clear how to solve this, but I think we can start making some progress. Since we're dealing with numbers and we can't use strings or repers, it's more common that we'll peel off elements from the end. So I think the way this would go is we would say, okay, I'm going to include the 4. I'm going to skip the 3. I'm going to include the 5. Now I've kind of built this thing up, which has a 5 and a 4 at the end. And what's left over in n is 3, 4, 2, 5. Let's say that as I've gone through and decided to keep the 4 and the 5, I now know that I need to build a palindrome that has a 4 and a 5 in it. So when I get to this point, I realize, oh, there's an option, which is that I could have the palindrome 4554 as one of the palindromes in here, but only if, after I've removed that and n is just 3, 4, 2, 5, if it's the case that k is contained within these digits, where k has to be the numbers that I've seen so far backwards. Okay, so if it's the case that k is in n, where k is the digits that I've decided to keep so far in reverse order, then I think we have a new choice, which is that we could have the palindrome, I think it's called pal, made up of k. So if k was 45, then we'd build 45, 54, and that would be something that is contained within n. And how do I know that? Well, I've found the 4 and the 5 in the suffix already, and I've checked to see that the 4 and 5 appear in the prefix, and so I know the whole thing is there. Now, how do we write down the logic of discard the number that's at the end of n or keep it? I think it would look something like, if I just want to keep k the same, that means I'm not really including n in more digits. That means that I'm going to make a recursive call ignoring the last digit of n. Otherwise, I will make a recursive call with the last digit of n being peeled off, but in this case, it will be captured as part of k. And what would that look like? That would look like keeping k as it is, and then adding in the last digit of n. So if we look at how this might go, originally n would be this whole thing, k would be 0. One of the recursive calls we would make would have n be everything except for the 4, and k would be 4. That sounds pretty good. And the recursive call from there, using this case, would be that we ignore the 3. So now k is 4, but n is 3, 4, 2, 5, 5. A recursive call from there, using the second case, would set k, well, n would obviously go down to 3, 4, 2, 5, but k would be set to whatever it was before. 4 times 10 is 40, plus 5 is 45. Then we could hit this case, which says if 45 is in here, which it is, then we have an option of 4554 as one of the palindromes within it. Yeah, great question. So how do you approach this problem? What are the steps? One is to recognize it is a tree recursion problem. You could do that from the syntax because there's 2 calls to big, or you could do that from the kind of nature of the problem, which is they were doing some search among all the possible like subsets of digits in here, which one's the biggest. Looks like a tree recursion problem. And so you have to look for a way to distill that into a sequence of choices. And a common sequence of choices that you have is keep the last digit or you don't. I mean, we've seen that in a few different examples. And so it happens to apply here. Sometimes it's not clear what kind of sequence of choices you need to make, but that is a big part of solving a tree recursion problem. So yeah, how you figure out what that choice is think about all the different possibilities that you need to consider. So all the different palindromes within here, and how would I enumerate that set? Well, all the ones that have a 4 at the end and all the ones that don't is a way of partitioning that set using an operation that I could repeat over and over again. So that's how you kind of figure out what choice you're going to be making. I guess that got us as far as thinking probably what we're going to do is call big where we keep the last digit and big where we don't. Now is the hard part, which is how are we going to represent this notion of keeping the last digit? It's not like we have a list called digits where we're appending the last digit to it. Instead, what we're doing is we're effectively reassigning k here. K either stays the same or k includes one more digit than it was before. So whenever you make a recursive call, a good way to think about what you're doing is that you're assigning these formal parameters to new values. So I guess that starts to explain what's going on here. The last piece is very problem specific. How would you know that you've found a palindrome? And therefore you want to consider that as one of the choices. You know, these two lines wouldn't show up in any other tree recursion problems. They're really just about palindromes because it happens to be that one way of describing a palindrome is that you find some digits within half the number And then you make sure those digits also appear in the other half of the number in reverse order. How would you discover this? I guess hopefully the definition of the palindrome would get you there. Like, how do you describe a palindrome? It's some digits, and then those digits also have to be contained in the other half of the number in reverse order. And by the way, this question down here would be out of scope for this semester, which is palindrome constant or logarithmic or linear quadratic? That was the lecture on efficiency that we made optional. You'll do a lot of that in 61B, so don't worry about that kind of thing. Yeah, so the question is, how do you control the order of the columns in the result in the SQL statement? And the answer is, well, however you list things out in the select clause at the very beginning is going to determine the column order. So if you write something like this, sorry, well, we're not even in SQL. I guess it doesn't matter because we'll just talk about it. If you write something like this, then you're aggregating, so you're going to get one row because we're not grouping, and that row will contain some name, and then the minimum salary, and then the maximum salary. And the order will be the name, and then the smallest salary anywhere in the records, and then the largest salary anywhere in the records. And you might wonder, like, what is the name? Well, this is the thing that's not terribly reliable. I think if you're aggregating in two different ways, then you can get the min or you can get the max, depending on the implementation. So, you know, really, it's not clear what name you would want this to provide, but I don't know exactly what it would do. If instead
I'm not even sure that the order of the columns will be what determines that. It could be something completely different too.
Right. Yeah. So if you just like edited this a little bit and you put the max first and then the min, would this affect the name? Like it could, but not in any kind of reliable way. So yeah, I mean, anywhere you're in the territory of mixing together aggregation and not aggregation, I guess like the really simple case is actually reliable, where you just aggregate in one way and that one way is a max. Then you're all right. Except if there are ties, you don't really have any control over which record you get. So you're not really all right there. Yeah, if you have two different aggregations, then who knows what will happen. But this would give you some name. I don't know which one, and then the max salary and then the min salary as the three different columns. If like you ever wanted to build a table and it had one column order, and then you wanted to build that same table with a different column order, well, I think the answer would be create table to give a name to the first table, and then select the columns from that table again, just in a different order.
Yeah, I think that's probably going to be implementation dependent. It's also sort of a weird thing to do. Like, what is? I mean, what's the right? If you can't think of what the right answer is, you probably shouldn't be asking the question in the first place.
All right, great question. So I think just for the sake of the recording, maybe we'll zip through the whole thing and then we'll address your question at the end. I know that takes a little bit longer, but it might be helpful for some folks. So here's summer 2019, question number 8. The ingredients table describes the dish and part for each part of each dish at a restaurant. So chili has beans and onions in it, and soup has broth and onions in it. The shop table describes the food, shop, and price for each part of the dish sold at each of the two shops. Okay, so you have to buy the ingredients. You can buy them from different shops, and then you have to put the ingredients together in order to make the chili. Cool. You can assume the shops table will only ever contain two shops, A and B, but otherwise, it should be the case that like we don't hard code chili in here, there could be any ingredients for any dishes. Select a 2-column table with 1 row per food that describes the lowest price for each food. Okay, so that's really just in here. And if you want to get down to 1 row for each food, then you have to group by food. And in general, it's fine to select the thing that you group by because you know that they'll be the same for every row in the group. And so there's no like ambiguity there. and then you need an aggregation expression in order to get the lowest price. Doesn't matter whether you capitalize this or not, but it is conventional to do so. Okay, select a 2-column table with 1 row per dish. That describes the total cost of each dish if all the parts are purchased from shop A. Okay, so in order to describe dishes and prices, we're definitely going to need to join the ingredients table and the shops table. Do we need to alias? Well, it turns out that all the names are different for all the columns: dish, part, food, shop, and price. So it doesn't hurt to alias, but you don't actually need to. You can refer to the different columns in the join table just by their original names. How would we do this? Well, first we want to get down to rows where we're describing to make this dish, I need beans, and those beans are bought from shop A and have price 2. So let's write some conditions to get that. It has to be that part equals food, meaning we're not talking about chili has beans in it, and by the way, broth has a price of 3. That wouldn't be useful information. We really need to know that we're talking about beans here and we're talking about beans there. And we want to make sure that we're talking about the right shop. A goes in quotes because it's not the name of a column, it's the value in a column. And so this refers to a whole column or the value within that column. This refers to an explicit value. If I wrote A here, it would break because there's no column called A. Okay. So now we have the right rows. The joined rows are chili, beans, beans, shop, prices. I can't read. 2. So now we need to group by dish. Why by dish? Well, we want 1 row per dish, right? Yeah, chili, soup, and beans. Now we want to know which dish we're talking about, and we want to know the sum of the prices. You can write just sum price, and what it will do is find the 2 different rows, the chili, beans, beans, A2 row, and the chili, onions, onions, A3 row, and sum the 2 and the 3 together to get the 5, but the dish is still chili in both cases. Okay, so not what you asked about, but now we've talked about it. In 2 different ways. Select a 1-column table of all foods that have a different price at each store. Oh, okay, so we have 2 options here. There's one with a where and there's one with a group by. Group by might work if we group by the food and then make sure that the min and the max are the same. Then I think they would have the same price. So I think this is also not the one you asked about, but the one that occurred to me first. Select food from shops, group by food. Okay, so now we have 1 row per each food, but we only want rows for the foods where the min price is equal to the max. I think that works. It's kind of a hack. Okay, what's the more explicit version? It's when we join the shops table with the shops table in order to have a row that describes the price at one shop and a price at another shop. Here we go.
Yeah, John, I think you're doing the opposite. They should have a different price.
Oh, thank you.
Same price.
Not equal. Different price. Thanks. Okay, so we do shops as A, we do shops as B. Here, we can no longer write just food because there's 2 different food columns. So we'd have to pick a particular food. Doesn't really matter which one we do because we're only interested in combined or joined rows where A.food equals B.food. And it's the case that they're from different shops. There's really 2 ways to write this. You could write it kind of a long way, which would be a dot shop equals A, and A dot shop equals B. Oh, sorry, and B dot shop equals B. That's one way to do it. And then we'll have to check this price thing. So A dot price does not equal B dot price. Now, there are actually different ways of expressing this thing. It's said that we could assume there's only two shops, so we could write it this way. But if we wanted to instead just say they're different, you might be tempted to write A dot shop does not equal B dot shop, which would give you the right rows, but I think it would give you a duplicate of each one. And the reason is you'd get a joined row that was like, you'd get an onions A3, onions B2, and you'd also get a row that said onions B2, onions A3. They would both have the property that they're different shops with different prices. And so you get two different onions rows, which you don't really want. So one trick to deal with this is to assume that since these have different names, one of them will come before the other alphabetically, at which point you'd only end up with the onions A3, onions B2 row, but not the onions B2, onions A3 row, because A comes before B. So if you saw in the solution that this was a less than rather than a not equal to, that was there so that you wouldn't get onions, onions, broth, broth, but instead just one onions and one broth.
Yeah, that's a little bit of a kludge, isn't it, John?
Yeah, but it kind of does show up a fair amount that when you're trying to find within one table matching rows that you have to worry about duplication. So that is something that's like worth learning about SQL.
Yeah, I thought your previous solution was a little bit longer but more explicit, which I think I like better.
Oh, great question. So if you didn't even say anything about the shops and you just found rows with different prices, would this be enough? This assumes that each shop only sells beans at a particular price, which I think is a reasonable assumption, even if it's not stated here. Probably should be stated here. Then do you need to make sure that they're from different shops? Well, you kind of know they're from different shops because they have different prices. So you don't really need to say that they're from different shops. I agree that that would be fine.
The next question was about Fall 2019 question 7C. We went over this question back in the Lecture 28 Q&A, but here we revisit it just to talk about the one trickiest part.
You have this expression that looks like this, and you're not allowed to times anymore, right?
Mm-hmm.
And so you have to turn this into a mul instead. But mul takes a list of values, a single argument, whereas times takes multiple arguments. So that's like the thing you're trying to deal with here, is converting from a procedure call that, let's say, has 3 arguments into a procedure call where you're only calling it on one thing. Well, let's review that really quick. Let's say we have times already, and we know how that works. And let's say we have mul, which takes a list of numbers and it multiplies them all together. So if I want to call mul, I can't call it on 1, 2, 3. I have to call it on a list containing 1, 2, and 3.
Mm-hmm.
The key part of this is that it doesn't work to say I call mul on 1, 2, 3. Why? Because this is a call expression. And a call expression says call 1 on the arguments 2 and 3, but 1 isn't a procedure, and so you get an error. So converting this, here's your expression, into this expression is a little bit more involved. You have to cons a mul onto another list where I guess the easiest way is to build a list where I have the word list and then I have the 1, 2, and the 3. And let's see what I got. Oh, I got the wrong thing. Cons mul onto, well, actually, I don't want a cons. I want to have two elements. I want mul, and I want the list 1, 2, 3. Okay, so that's how you build it. Well, what if we wanted to build it out of the parts of this expression? Well, that's like a little bit more involved. We still want a 2-element list with mul. And in this case, we want the second list to start with the word list, but then the rest of it should be whatever is the rest of expr.